We are starting into chapter 3 today. We're going to be working on section 3.1, representing relations. So the first thing we're going to do is let's talk some vocab. A relation is a set of ordered pairs that relates one value to another. Okay, one value to another. So in other words, we have these ordered pairs and the relation is how does this number relate to that number? The domain of a relation is the set of all first numbers of the ordered pairs. Some other names that we give the domain is we call it also input values. Okay, that's just an easy way to remember it. So domain input values of a relation is the set of all first numbers of the ordered pairs. In other words, they are the x values. The range or the output values of a relation is the set of all second numbers of the ordered pair, or the y values. Okay, so the key there is we're looking at the y values for range, we're looking at the x values for the domain. Just real quick, remember that an ordered pair is an x value comma a y value. And when we graph that, remember we always graph the x value first, left or right. And then we graph the y value second, and that's the up or down. So what we do is, like, for example, if I give you the ordered pair 2, 3, I would go right 2, up 3, put a dot. Okay, put our point. All right, there are 4 main ways that we use to represent a relation. We will be addressing 3 of those today. The first one is the mapping. And all we do on a mapping is we have this bubble for our domains, we have a bubble for our ranges, and we draw the arrow to show the relationship. Typically, we like to write our domain and our range from least to greatest. It just makes it easier, just list it out least to greatest. A table is basically like a mapping. But a table just goes straight across, 3 to 5, -4 to -2, 0 to 2. The first row in your, or the first column in your table is your x values or your domain. The second value is your y values or your range. Then a third way that we represent this is by putting them on a graph. So if you notice here, if we go 1, 2, 3, 4, negative, and then down 2, that is this point on the graph. Okay, and then our second one there is 0, up 2. And then our third one is 3 to the right, up 5. And that would be those 3 points from a table to a graph. And then the fourth way that we are going to address later on is an equation to represent those. Okay, so we have a mapping, a table, and a graph. Those are the 3 that we're mainly going to focus in on, but then we also have equations as well. So let's practice here real quick. So express this given relation as a table, a graph, and a mapping. All right, so I'm going to start over here. I'm going to go 2, 0. I'm going to go 0, 4, 3, -5, and -3, -5. Okay, so there's my table. Then I'm going to go to graph it. So now to graph it, I'm going to go right 2, nowhere up or down. I'm not going to go right or left any, but I'm going to go up 4. I'm going to go to the right 3, down 5. And I'm going to go to the left 3, down 5. And it looks like that. So there would be our graph. The third one is our mapping. Remember, we would like to list these from least to greatest. So the smallest number for my x's is -3, then 0, then 2, then 3. Smallest number on my y's is -5. I have a 0 and I have a 4. Now notice I did not repeat the -5 in the mapping. I just wrote it one time. Because now what we're going to do is we're going to draw an arrow. So -3 goes to -5. 2 goes to 0. 0 goes to 4. And 3 goes to -5. So it looks like that. Then it says determine the domain and range of the relation. Remember, domain, that's our x's, range is our y. So my domain is -3, 0, 2, 3. My range is -5, 0, 4. Okay, so that's how we do that, and we express those relations as a table, a graph, and a mapping. Okay, now can we go backwards? Meaning if I give you a table, can you list for me the ordered pairs? So if I look here on the first one, my first ordered pair, remember, is in parentheses, and we go x value, which would be -1, and it goes to a -5. My second x value is 4, 7, and then my last one is -2, 3. Okay, if we look at this second one, it's points on a graph. So here I'm going to go left 2, so -2, 1, 2, 3, 4, down 4. That's my first point. My second point is -1, left 1, 1, 2, 3, up. And my third point is 1, 2, 3, 4, 5 to the right and up 1. So that would be that ordered pair set. And in my third one here, I'm just following the arrows. So my first one would be 1, 5. My second one would be 5, -1. And my third one, -6, -1. Okay. Now, we also can talk about analyzing graphs here. The values in the domain correspond to the independent variable in a relation. The independent variable, usually x, has a value that is subject to choice. In other words, you get to choose what your independent variable is doing. So, for example, I might want to know what's happening on day 12. So that would be a number I would plug in for the independent. Okay. In this graph, the independent variable here would be days. Okay. So I'm looking at how much days I have, and that's the independent. Then the values in the range correspond to the dependent variable of the relation. The dependent variable is the variable in a relation, usually y, with values that depend on x. So for example, here, however many days I'm driving, that's what's giving me the driving time. So that's why driving time becomes the dependent. So in the graph shown, the dependent variable is the driving time. So the driving time is based off of the number of days. Okay, so if we take a look at this one, the graph represents the number of text messages sent by Nora throughout the day. So when I look, identify the independent and dependent variables. So here is text messages sent dependent on the time of day, or is the time of day depending on the text messages sent? And it would be the first one, right? So the independent variable is time. The dependent variable is the text messages sent. Okay. So then as you move from left to right, so I'm going to start here and I'm moving to the right. So from left to right. As you move from left to right along the graph, time does what? Well, time increases. And the number of text messages sent, that's going from bottom to top here. If you notice, they're getting bigger. So that's going to increase as well. So as you move from left to right along the time graph, time increases and the number of text messages sent increases until the graph becomes a flat line. Now, what I'm meaning by that is this right here. See how it flattens out? It's not increasing. So during that time, the horizontal line means that the time is increasing, but the number of text messages sent stops. They're not sending anymore. During this time, Nora stops sending text message. Then she continued to send text messages until she stops again. And that is right here. There's another stopping period. Finally, Nora began sending text messages again. And we know that because now the graph is going up. So as the graph goes up, that's when she's sending more text messages. When it gives you that horizontal flat line, that's when she's stopping. Okay? So if I give you two other examples, can you identify for me the independent and dependent? So it says the average price of a ticket to an amusement park steadily increased over time. So time here would be our independent, because the price is increasing over time. So the price is based off of the time. So the average price of a ticket is the dependent variable. The air pressure inside a soccer ball decreases with time again. So time is the independent, and air pressure is the dependent. Now, here's the thing to remember with this. The math that we're going to be doing is not necessarily real challenging like last chapter, but there's a lot of vocab. So you got to make sure that you're studying this vocab so you know what the word domain, range, mapping, graphing, T-tables, that type of stuff looks like. What does it mean to be a relation? We're going to be adding a lot of words to this, so you need to make sure that you're studying that vocab throughout this chapter.